Welcome back. Today's goal of this lecture. Today I will see what is the singularity. Singularity or singular point. What is singular point? Let f be complex function, then a complex number z equal to z naught is said to be singular point or singularity of f if z equal to z naught is not regular point. Regular point means in this point function is analytic. If z equal to z naught is not a regular point, then z equal to z naught is called singular point. Or z naught is regular point, but in a neighborhood of z naught there is a regular point. That means in z naught function is not analytic, but in the neighborhood of z naught their function is analytic. Then this point z naught is called singular point. Singularity is two types singularity: isolated singularity and limit point singularity. What is the isolated singularity? Singularity is a singularity z equal to z naught of a function f is said to be isolated singularity if there exists neighborhood of z naught containing no other singularity of fz. If z1, z2, z3, z4 are singularity of fz, that means there exists a neighborhood containing z1 in which there exists no other singularity. Similarly, containing z2 there exists no other singularity. Containing z3 there exists no other singularity. Containing z4 there exists no other singularity. Containing z4 there exists a ball where function has no other singularity. So z1, z2, z3, z4 of the function fz is called isolated singularity. So definition is a singularity z equal to z naught of a function is said to be isolated singularity if there exists neighborhood of z naught containing in this neighborhood there are no other singularity. Consider fz equal to 1 over z minus 1 times 1 over z minus 2. Notice z equal to 1 and 2 are isolated singularity. Because if this is 1 and this is 2, in the neighborhood of 1 there exists no other singularity. Similarly, in the neighborhood of 2 there exists no other singularity. So 1 and 2 are isolated singularity. Similarly, if fz equal to 1 over sin pi z, then z equal to n pi is an isolated singularity. Okay. Non-isolated singularity. What is the non-isolated singularity? A singularity z equal to z naught is said to be non-isolated singularity if every neighborhood of z naught if every neighborhood of z naught contains other singularity, or z equal to z naught is a limit point of singularity. Z equal to z naught is a non-isolated singularity when in the neighborhood of z naught there exists other singularity also. Or z equal to z naught, this is the limit point of the singularity. Okay. I hope my all viewers have understood what is the non-isolated singularity. There exists three types of isolated singular point. One, removable. Second, pole. Third, essential. This goal of this lecture, today I will see these three type of singularity. Consider fz equal to 1 over sine 1 over z. Notice here sine 1 over z equal to 0, that imply 1 over z equal to n pi, that imply z equal to 1 over n pi, and the set of singularity is 1 over n pi, where n belongs to integer, and limit point of this singularity is 0. That means 1 over n pi is isolated singularity, and 0, since 0 is the limit point of the singularity, so 0 is non-isolated singularity. Okay, I hope my all viewers have understood. Singularity, if limit z tends to z naught, fz exists finitely, but f is not regular, that means f is not analytic at this point, then f is removable singularity. And pole, if removable singularity at the point z equal to z naught, and pole if limit z tends to z naught, z minus z0 to the power m, fz equal to L, which is not equal to 0. That means if this value is exist finitely, here m is the order of the pole, then we can tell this fz, there exists pole. But limit z tends to z naught, fz not exist finitely. If limit z tends to z naught, fz not exist finitely, then z equal to z naught is called fz. At the point z equal to z naught, the function fz has a pole. And if neither pole nor non-removable singularity, then there exists always essential singularity. I hope my all viewers have understood this is easily. Okay? OL. Example, fz equal to sin z over z when z not equal to 0, and when z equal to 0, then this value is 7. Obviously the function is discontinuous because limit z tends to 0, sin z over z, this value is 1, which is not equal to f of 0. So z equal to 0 is removable singularity. But function is discontinuous at the point 0 because this limiting value is not equal to f of 0. So the function is discontinuous, but z equal to 0 is a removable singularity. Next, fz equal to e to the power z minus 1 over z. Obviously this is the 0 by 0 form, and limit z tends to 0, e to the power z over 1, this value is finite. So this singularity is removable singularity. So z equal to 0 is called removable singularity. Okay. Limit z tends to 0, these fz exist finitely, so z equal to 0 is called removable singularity. Also, if you expand the series, then 1 over z and e to the power z means 1 plus z square over 2 factorial z cube over 2 factorial so on. Here minus 1 and here 1 and minus 1 would be cancelled. So this value is, if you divide this part as z, then this value would be 1 plus z over 2 factorial plus z square over 3 factorial up to so on, and there exists no principal part. So, since fz at z equal to 0 has no principal part, so z equal to 0 is removable singularity. Fz means sin z over z cube when z not equal to 0. If pole, that means there exists k belongs to natural number such that bn equal to 0, and this is true for n greater than k. After n greater than k, this bn equal to 0, and then the largest n such that bn not equal to 0 is called pole of this largest n such that bn is not equal to 0. This is called pole of order k. That means principal part have a finite term. Notice here sin z over z cube. At first see the Lorentz series expansion. Here 1 over z cube. We all of us know sin z means z minus z cube over 3 factorial plus z to the power 5 over 5 factorial so on. And after calculation, this value would be 1 over z square minus 3 factorial plus z square over 5 factorial so on. And notice here principal part contains only two terms. This is the principal part. Then, and degree of highest degree is 2, so z equal to 0 is a pole of order 2. And we all of us know, if limit z tends to z0, z minus, since this is the pole of order 2, that means z minus 0 whole square sin z over z cube, this value is limit z tends to 0 sin z over z, and this value is equal to 1. Since this value is finite, so z equal to 0 is a pole, and here the power is 2, is pole of order 2. I hope my all viewers have understood this question. Fz equal to 1 over e to the power z minus 1. Notice limit z tends to 0, 1 over e to the power 0 minus 1, this value is 1 minus 1, this value is infinity. So z equal to 0 is simple pole of this function. Since limit does not exist finitely, also since this is the simple pole, so limit z tends to 0, z over e to the power z minus 1, notice this is 0 by 0 from, so this value would be limit z tends to 0, 1 over e to the power z, and this value is equal to 1. So z equal to 0 is a simple pole. Since this value exists finitely and order of z is 1, so this is simple pole. I hope my all viewers have understood clearly. Okay. Fz equal to tan z, we can write this as sin z over cos z, and the function is not defined when cos z equal to 0. This is equal to cos 2n plus 1 into pi over 2. That means z equal to 2n plus 1 into pi over 2, where n belongs to integer. So there exists infinite pole, and all poles lies on the real axis. I hope my all viewers have understood this is. Essential singularity is this singularity which is neither a removable singularity nor not pole, and a point z equal to z naught is called essential singularity if limit z tends to z naught fz does not exist finitely. Then this is called essential singularity. As for example, fz equal to sin 1 over z. Z equal to 0 is an essential singularity because sin 1 over z means 1 over z plus 1 over z square, 1 over z cube, 1 over z to the power 5, so on. This principal part exists infinitely. So this is neither pole nor removable singularity. So z equal to 0, here essential singularity. Similarly, if you consider e to the power 1 over z, then this is equal to, the principal part would be 1 plus 1 over z plus 1 over z square over 2 factorial plus 1 over z cube over 3 factorial, so on. Here principal part would be continue, so this is z equal to 0, also here essential singularity. Fz equal to tan 1 over z. Tan 1 over z means sin 1 over z divided by cos 1 over z, and the function is not defined when cos 1 over z equal to 0. That means 1 over z equal to 2n plus 1 into pi by 2. That implies z equal to 2 over pi times 2n plus 1. That means singularity is where n belongs to integer. Singularity is the set A equal to 2 over pi times 2n plus 1 where n belongs to n belongs to integer. And notice here limit point of the singularity is 0. So 0 also would be included, and this is the limit point of the singularity. So these are isolated and these are non-isolated, and non-isolated singularity is always one type. This is non-isolated essential singularity. There exists a shortcut trick e to the power p over q, sin p over q, cos p over q. For this type of function, either removable singularity or essential singularity. There exists never pole. As for example, notice here e to the power z square over 1 minus cos z. This is look like e to the power p over q, and 1 minus cos z is not defined. Cos z equal to 1. This is implies z equal to 2n pi where n belongs to integer. So since there exists two type of singularity, either essential or removable singularity. So z equal to 2n pi is an essential singularity. And notice here e to the power z square over 1 minus cos z. Limit z tends to 0, e to the power z square over 1 minus cos z, we can write this as e to the power limit z tends to 0 z square over 1 minus cos z, and this is equal to 0 by 0 from. So this value is equal to e to the power limit z tends to 0 2z over minus sin z, and this is also 0 by 0 from. This is equal to e to the power limit z tends to 0 2 over minus cos z, and this value is equal to sin cos z here will be plus sign. This value is e square. This is the finite term. So z equal to 0 is removable singularity. And at the point z equal to 2n pi is the essential singularity. So z equal to z equal to 0 is a removable singularity, and z equal to 2n pi is an essential singularity, because this is the look like e to the power p over q. Such type of function e to the power p over q, sin p over q or cos p over q, there exists either removable singularity or essential singularity. Today I will stop here. In my next video I will see some more example about singularity. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.